So far we have learned 3 ways to solve a quadratic. The first way is graphing, and I have been allowing you to use a grapher for that, even though I know that you know how to graph. Factoring, and square roots. Okay, so this is going to be our 4th way, and it's called completing the square. And you'll see why it's called that in just a second. All right, so when to use this method? If you're looking at a function that's in standard form, ax squared plus bx plus c equal to 0, remember it has to always be set equal to 0. And once you get it in this form, if a is 1 and b is even, then this would be your best method. So the way it works is that would you just use this chart over here, and this is on page 56 in your workbook if you want to help work it out. The first tool that you need to be able to do a completing the square successfully is to be able to take the b, cut it in half, and square it. And that makes it so that the square is complete. Okay, so all this is doing is it's teaching you how to do that correctly. All right, so in this case I would take the b, which is 2, I'd cut it in half and square it. So that would give me 2 over 2 is 1. That would give me 1 squared, which is 1. So the expression would read x squared plus 2x plus 1. That's what I'm going to fill in for c. And the reason I want to do that is because now this can be factored as x plus 1 times x plus 1, which is x plus 1 squared. All right, so let's see another one. Again, the tool is to take the b, cut it in half, and square it. So that would be 2 squared, which is 4. Therefore, c is going to be 4, and it would be written this way. Again, the reason we want to do that is so that it can be factored into x plus 2 times x plus 2, or x plus 2 squared. So the reason this is called completing the square is because we are making the function a perfect square. Okay? And again, this is just a tool that you need to be able to solve correctly. So we're going to take the 8, cut it in half, and square it, and we'll get 4 squared, which is 16. So therefore our new equation would read x squared plus 8x plus 16, which again can be factored as x plus 4 squared. Now would be a good time for you to pause the video, try the last one yourself, and then come back and check it. So 5 squared, which is 25. So the function would read x squared plus 10x plus 25, again factored as x plus 5 squared. Again, that is the skill that you need to be able to finish a problem. In the next slide, we'll start solving them completely. Okay, now here's what our examples will actually look like. It's a quadratic formula. I'm sorry, it's a quadratic set equal to 0 in the standard form. So the very first step that we need to do is to make this have my a and my b, and then move the c to the opposite side. So we're going to leave some space here, and we're going to put our equals over there, and we're going to take this 6 and move it to the other side by subtracting 6 to both sides. Okay, and what that's allowing us to do is to find that c, like we did in the last page, find that c that will make this a perfect square. In other words, we're completing the square. All right, so what we're going to do is take the b off to the side. We're going to cut it in half and square it. So negative 14 squared is negative 7 squared is 49. So I'm going to add 49 here, which helps me complete this square, but I also have to do it to the other side. Okay, so now in my next step, this part over here is now factorable. I can use x minus 7 squared, because x minus 7 times x minus 7 is what you see there on the left hand side. And now I'm just going to add negative 6 plus 49, which is 43. Now this question is set up as a perfect square. I'm sorry, as a square root method. Whew, sorry, it's a long day. Okay, so we're going to square root both sides, and I'll be left with x minus 7 equals positive negative, remember I have to do that, square root of 43. Now we're going to add this 7 to the other side, and my final answer looks like this. Okay, let's try another one. Again, the first step is to isolate the a and the b, move that 7 to the other side, which makes it negative because I have to subtract it to both sides. Now we're going to take the b, cut it in half, and square it. That gives me 4 squared is 16. I'm going to add 16 to both sides. This is the step that most students miss when they do it on the test. So I'm telling you now so that hopefully you won't skip it. Okay, now we're going to rewrite this as z plus 4 squared, which is what this factors into, and that's going to be equal to 9. All right, now we can square root both sides. So I have z plus 4 equals positive and negative 3. Well, what that means then is that I need to solve z plus 4 equal to 3 to get an answer, and z plus 4 equal to negative 3 to get an answer. So I'm going to subtract 4 here. One of my z's is negative 1, and the other one is negative 7. Okay, this is another one of those times where I want you to pause and play. Pause the video, practice on your own, and then play it when you need to see the steps. Okay. Okay, so what I did was I added 2 to both sides here to get that to the other side. I'm going to take negative 6, cut it in half, and square it, and that will be positive 9 on both sides. So I have r minus 3 squared is 11. Now I'm going to square root both sides. So r minus 3 is equal to positive negative square root of 11 because it cannot be broken down. And then I'm just going to add 3 to both sides. So my final answer looks like that. Okay. And next one, same thing. Let's move that 28 over to the other side. I'm going to take 10, cut it in half, and square it, and that gives me 25, which again I add to both sides. This will be x plus 5 squared. This will be negative 3. So when I square root both sides, I'm going to have x plus 5 equal to I squared of 3, plus or minus. I almost forgot that part. Now we're going to subtract 5 to both sides. So x is negative 5 plus or minus I times the square root of 3. So this is a parabola that actually has an imaginary solution, or 2 imaginary solutions. All right, and then in the last one, I don't like the way this is set up because remember I said that a had to be equal to 1, and in this case it's not. So what I'm going to do is make it that way by factoring out a GCF. Like that. Now, all I'm concerned with then is this middle part. So I'm actually going to work this question using just the middle piece. Okay, so I'm going to take 8, cut it in half, and square it, and that gives me 16. Add 16 to both sides. Okay, so I have t plus 4 squared equals 19. Square root both sides. Okay, and there you have it. Now you will practice and hopefully get better and better at this so you can do it as quickly as I did.